Now what we want to do is multiply and divide algebraic fractions. Now the key here is to factor numerators and denominators. Cancel before we expand, because you don't really want to expand that out and then try and simplify. It won't work. Trust me, it won't work. What you've got to do to make this in its most simplest form is factorize. And that's what I said before. Factorize first, factorize second, factorize third before you think of anything else. So to do multiplication division of algebraic fractions, start to factorize. Because again, you can't just cancel willy-nilly and try and kill terms off. Not allowed, because they're separate terms. Like you're doing division, you've got to follow your correct order of operations, and you just can't cancel terms when they're being added. So again, you've got it like an implicit bracket around here of these ones. You've got to keep thinking that like it's this whole thing divided by this whole thing. They're implicit brackets, and what do you got to do first? You got to simplify what's inside the brackets. Can't do that, and it's not nice terms because they're adding and subtracting. And once you get them all in multiplication and division, you can start to cancel things, but only when it's all multiplication and division. It's subtraction here, so that's why we need to get our brackets. So how do we go about it? Well, I look at my right hand side first here. This term here, I can't simplify that any further, so I'm going to have to simplify this one. What I'm looking for is something to cancel x minus 11 and x minus 2. So when I look at x squared minus 121, hopefully it jumps out at me that's going to be the division of the difference of two squares, and then I can look at that and go, well, it's going to be 11, so I'm going to have an x minus 11 up here, so I can start to cancel out when it comes to time. And down the bottom again, difference of two squares nicely, and I'm able to cancel there because I've got a bracket there, the bracket there. It's all multiplication and division, and then the x plus 11, x plus 2 on there. Now, it's possible to do if you expand it out and get all your terms there, but then you're going to have to do polynomial division. Now, trust me when I tell you, factorizing is much easier than polynomial division. It's doable, very doable, because you'd end up with that, with a remainder of 1 over x plus 2. Very doable, but not easy. So what we need to be doing is be careful and be factorizing. In this one we don't have to factorize, but we can do some cancelling. But remembering, when we divide by a fraction, it's the same as multiplying by the reciprocal. Remember, if I'm going to divide something by 2, I'm going to split it in. It's really the same as multiplying it by half, and vice versa. I'm going to divide something by half. Something's going to go in to something else. It's the same as multiplying by 2. So I'm taking the reciprocal there. So once I've done that first step, I can then start to cancel and have a look. I've actually multiplied it out, then done the cancelling, but I could have done the cancelling earlier on. So, and got those terms like the b3 cancelled, gives you just the b to the power of 1. The c cancels, gives the c to the power of 1 there, and that's where we end up with our terms there. Try not, because they're remaining on the bottom, try and keep them there, not take them up. If you want to write that as a half, b to the power of minus 1, c to the power of minus 1, go for it, not a problem. But it's quite happy to leave it as 1 over 2bc. Again, question 3, we're looking at, well, there's nothing much to cancel, even though we'd love to cancel that x with the x, can't do it. But what we're going to do is change the division to multiplication, put our x in the numerator, factorize x squared minus 4, difference of two squares, and again we've got a trinomial, and hopefully at this stage we're really good at factorizing our trinomials, and we can see, well, it's going to be minus 2 and plus 3, and we've got there, and then we can start to cancel because we've got an x minus 2 and an x minus 2. Our x will cancel, it goes into x cubed, x squared times, and that's all we can cancel, so we're going to write down that, and it's going to be as simplified as we're going to get it. Can't go any further. So in question 4, again, the left hand side here, pretty simple, doesn't change much, but we're going division to multiplication, turning it upside down, factorizing x squared minus 16, the difference of two squares, and x squared minus x minus 12 comes to minus 4 and positive 3 there, and then we can start to cancel what we've got there. We're left with x plus 1 on top, x plus 4 on the bottom. So that's what we need to do with all those. Need to factorize first. Always factorize before we start to cancel. Keep that in mind as you go through and do that. Now, let's have a look at some simplifying some compound fractions. Now, once we see this, like a lot of times these ones you're going to throw in the calculator. I know you're going to throw in the calculator, so try and keep in. But I want to show you firstly with a numerical one, then with some algebra, how we do that. So what we're trying to do this one is we're trying to get rid of fractions as much as possible. We've got two fractions subtracting over an addition of two fractions. Well, how do we do that to get rid of the denominators in these ones here? Multiply the top and bottom by the lowest common denominator of all these fractions, which would be 12. 2, 3, 4, and 6 go into 12. So if you multiply every term by 12, so I'm going to multiply the top by 12, bottom by 12, it's really multiplying by 1. You're not changing the value. Half of 12 is 6. A third of 12 is 4. A quarter of 12 is 3. And 1/6 of 12 is 2. And then you can do 6 minus 4 over 3 plus 2 is 2/5. So there's the process we want to do. If we look at it for this one, this can be written as 1 on x minus 1 on y over 1 minus x squared over 1 minus y squared. The lowest common denominator they all go into is x squared y squared. So if we multiply the top and bottom by that, the x squared y, so well, the x would cancel with that one, so we get an x squared with the y squared. The 1 on y times x squared y squared, well, the y would cancel with the y and we get x squared y. 1 on x squared times this, well, the x squared cancels and we're just left with y squared. And 1 on y squared times all this would cancel the y squared, so we're left with the x squared there. Now, can we simplify a little bit further? We can. We've got a common denominator there, so we can get the xy outside of y minus x, and y squared minus x squared is the difference of two squares. It cancels, gives us xy over x plus y. So there we go. There's some ways we can manipulate and do multiplication and division of fractions. Again, looking for cancel and looking to factorize first and cancel. Looking to get out in the last couple, looking to get our lowest common denominators and play around and to try and simplify our fractions and make them much more easier to manipulate.